Today we're going to be talking about section 1.3, and it's on solving linear equations. An equation is a statement that relates two expressions are equal. And a linear equation, when we talk about it in one variable, is an equation that can be written in the form ax plus b equals 0, where a and b are constants and a cannot be 0. So we're going to also talk about the solution. And a solution is if when we substitute a number for the variable into the equation, the result is a true statement. So if you plug a number in, it makes it true, that means it's a solution to the problem. Equivalent equations are equations that have the same solution. So when we look at transforming the properties of equality, basically they're saying this. We have four of them here: addition, subtraction, multiplication, and division. So essentially it is, if we do the same thing to both sides of the equation, it's not going to change the answer. Those are the properties of equality. So if we talk about addition, if you add the same number to both sides of an equation, they'll be equivalent equations. Just like a teeter-totter. If you add weight to one side, you got to add weight to the other side to balance it out. Same thing is true for all of these properties. Subtraction. You can subtract the same number from both sides of the equation. It will produce an equivalent equation. Multiplication and division are a little bit different because we can't use 0. So if we multiply the same non-zero number from each side, we'll get an equivalent equation. And if we divide the same non-zero number from each side, we'll get an equivalent equation. So if you do the same thing to each side of the equation, you will produce an equivalent equation, with the exception of multiplying or dividing by 0. So in example 1, we're going to look at solving an equation. So we have 2/3 x minus 7 equals 5. And our goal is always, when we solve these, to get the x by itself. So we have to use the properties of equality to make that happen. So I have a minus 7, so that means I'm going to add 7 using the addition property of equality to do that. So I'm going to have 2/3 x equals 12. And I have 2/3 times x, so I want to get rid of the 2/3. So I'm going to divide by 2/3, which is the same as multiplying by 3/2. So I'm going to multiply the numerator, or both sides, by 3/2, because these will cancel out, and I'm going to have x equals, and 12 times 3/2 is going to give us 18. And so there is our answer. Now, you can always check to make sure that this is correct by plugging it back in, because that's what a solution is. So if we put it in, 2/3 of 18. Well, 18 divided by 3 is 6. 6 times 2 is 12. 12 minus 7 is 5. So the left side would be 5. The right side would be 5. It's an equivalent equation. Therefore, that is our solution. Example 2 says write and use a linear equation. Your total cost for a book, including sales tax, is $23.32. All right, so we're going to write that. Total cost for a book. We don't know what it is. We're going to call it X. Okay, so that's the cost of the book plus the cost of the sales tax. So 6%, we write that as a decimal, is 0.06 times whatever the book cost. And that is means equals 23.32. So what we're going to need to do is simplify this and solve it. So we're going to have 1.06x equals 23.32. Now I have 1.06 times x. Well, inverse operations tells us if I have a multiplication, how do I undo the multiplication? I divide. So we're going to divide by 1.06. If we do it to one side, you got to do it to the other side. So we're going to have x equals 23.32 divided by 1.06, which is 22. So the cost of the book is $22. So we're going to jump to a couple guided practice questions, 1 through 4. I want you to take a couple minutes to do those. You can go ahead and pause the video, hit play when you are ready to resume. And here are the answers to those 4 guided practice questions. Jumping down to example 3, if we look at this problem, now we notice that we have variables on both sides of the equation. So again, our goal is always to get the variable by itself. So to do that, we're going to have to put them on the same side first. So you can move one way, you can move them all the way to the left, or you can move it to the side which is positive. There's a couple different ways you can do it. But I'm going to move my variables to the side that makes them positive. So I'm going to go 13 minus the 8. So that's going to give me 5y. And then I'm going to have to move the 9 to the opposite side because I want the variables on the opposite side as our constants. So negative 16 minus 9 is negative 25. And now you divide by 5 and you get negative 5. So our answer is a negative 5. Example 4. We're going to solve the equation with the distributive property. Again, we've looked at this already this year. And you've looked at it hundreds of times in the past, but we're going to do the distributive property. So that's going to give us 8x minus 36 plus 5x equals negative 30 plus 3x. Now we're going to combine our like terms. So we have 2 of them here, so that's a 13x minus 36 equals negative 30 plus 3x. And we're going to put our variables on the same side. I'm going to move my 3x over. So that's going to be subtracted. So that's going to give us 10x. And I'm going to move my negative 36 to the other side. So that'll add 36. So that's going to give us 6. So x is going to equal 6/10, which reduces to 3/5. And once again, you can always double check to see if you have your answer right by plugging it back in. Solving equations, you can be 100% sure that you got it right. If you substitute it back in and the left side equals the right side, you know you have the correct answer. Example 5. It is a work problem. It says it takes you 45 minutes to mow the lawn. Excuse me. It takes your brother 30 minutes to mow the lawn. How long does it take you to mow the lawn if you have 2 mowers and work together? So we're going to look at how to set this problem up. If you want another example, there's another example of it on page 20 in your book as well. But what we're going to do is we know that when we set this up, we're going to start with our rate. So it takes you're mowing 1 lawn, and it takes you 45 minutes. So there, it's 1 over 45 times t. And it takes your brother, he's mowing 1 lawn at a rate of 30, and it's going to take you t. Now, it's going to equal 1 because we're only mowing 1 lawn. If we were mowing 7 lawns, then we would put 7 in there. But in this case, we are only doing 1 lawn, so that's what it would be. Now, you can do this a couple of different ways. You can just simplify this by turning it into decimals. You can get a common denominator using fractions. And that's what I'm going to do. I'm going to get a common denominator. And it's going to be 90. Because I know that if I get to 90, I have to multiply that by 2, 45 times 2, so this is going to be 2. And I have to multiply this one by 3, so top and bottom by 3, so that's going to give me 3. So this is really going to be 5 90ths t equals 1. Multiply by the reciprocal on both sides. Again, these cancel out, and we're left with t equals 90 over 5. And if we simplify that, it is 18. So it takes the 2 of you 18 minutes to mow the lawn. So if you work together, it'll only take 18 minutes to mow the lawn. So now we're going to jump ahead to a bunch of guided practice questions. There's 6 of them here, so go ahead and do those when you. Go ahead and hit pause, and then you can hit play when you're ready to move on. And here are the answers to guided practice questions 5 through 6 or 5 through 10. Notice in questions 9 through 10, I got a common denominator in those problems. If you want to turn those into decimals, you can do that as well, but make sure you know how to use common denominators. So in section 1.3, we are solving linear equations. Our goal is always to get the variable by itself. We used order of operations. We used the properties of equality to solve these linear equations. So your assignment for section 1.3 is on page 21. Make sure you know how to do all of those problems.